So this is a status report on Psyche. And, you know, Psyche is really the first mission to what is likely a metal, an M-type asteroid or a metal-rich asteroid. This is their cover page. And here is the local color of, you know, the size of Psyche, and it's about the size of Massachusetts.
Hey, Bonnie?
Yeah.
If you go to view, you can do full screen. So on the top panel, actually the second row, not there, yeah. So you see the file, edit, and view. If you go view and say full screen, perfect.
How's that? Okay, thank you. Yeah, I'm not used to, this is a PDF. I'm not used to running PDFs. Okay, so first of all, the science goals of Psyche. Now, we can't see the Earth's core. Psyche is believed to be a protoplanet that, you know, possibly differentiated, had an iron core, and then had its mantle kind of stripped away. So we're looking at a stage of planetary evolution, namely a core. So if we directly examine the interior of a differentiated body, which we can't otherwise see because the terrestrial planets all have mantles, we can explore a new type of world that is not made of rock or ice, but of metal. Okay, and here are the major instruments on Psyche. I'm not a member, by the way, I'm not a member of the Psyche team. These are Lindy's geographs, and I'm you know, walking through them. All the stupid stuff that I say is totally my responsibility. Okay, so the first objective is to determine whether Psyche is a core or if it is unmelted material. So it can either be a high nickel core, a low nickel core. It could be a rubble pile. It could be there's something else that we haven't envisioned. And the second objective is determine the relative ages of surface regions. This would just be using the bread and butter of crater counting in geologic sciences. Okay. To look at light elements in the core, this is also condition, you know, whether they're oxidizing or reducing conditions of core formation. And also to do the other bread and butter area of characterizing Psyche's morphology. Here's some maps, some altimetry maps from Ceres and Vesta, showing their morphology and shape. Okay, the other thing that might be seen there is craterine processes in a metal-rich asteroid. Here is a paper by Marchi et al. Studying craterine processes on metal-rich surfaces. So this could be a whole new type of geomorphology. Okay, so here's the thing I think that, you know, is most important to SBAG. And I did talk with Lindy about a week ago, asking her if, you know, are there any things that you want us to focus on? Are there any problems? And it's really coming along Psyche is really coming along pretty well. COVID has been a challenge, but they're in phase CD implementation. I see the PDR and CDR here is back here, but I think it's KD PDR, and we are here. They're on schedule for a launch in August of 2022. There's a Mars flyby, and I'm sure there are plans to possibly do any science there. And there's arrival at Psyche in January 2026. So this schedule is all reasonable. They're on schedule for the launch and for the arrival. I think yesterday Lori mentioned that they made the decision on the magnetometer on the spacecraft. So, you know, there are things going on, but everything is fine. And, you know, as I said, I'm not a member of the team, so I probably can't answer questions, but according to Lindy, everything is going fine. One of the things is, see, I don't have the, I don't have the view graph here, but one of the things was the density of Psyche and whether it is really an M-type asteroid, because I mean, there was an early estimate of a density of about 7 grams per cc. And now it looks more like it's kind of in the 3 to 4 range. So it could be a rubble pile or have a lot of rocky material mixed with it. And that's one of the big questions and things that will be discovered and or studied by the mission. So I'm going to stop sharing now. We're a little bit ahead of time. Okay. So Maitreya, I'm going to hand it over to you as the host of the morning session or the late afternoon session if you're on the East Coast, and have the other missions present.
Thanks, Bonnie. Good morning, everyone. Should we just continue with the next missions because we're really
Yeah, I actually see Hal online for Lucy. We have, you know, Lucy Harajanis and then the Vera Rubentel. I see Hal, so I think he's ready to go.
I can go, or we can wait to stay on schedule. It's up to you, Bonnie.
Well, one thing we could do is if anybody has any, you know, as I said, I'm not a member of the Psyche team, so I don't feel qualified to answer questions about it. But if anybody has any comments about the recent research on Psyche, anything they want to share about the mission or about Psyche, you know, they could do it at this point. You know, I think in the by going into the chat.
Tom Statler says, just wondering whether anybody who's been doing spectroscopy on Psyche can say something.
Okay, and I also see here David Lawrence. I have a private thing that he's the instrument lead for the Psyche GRNS. So if there are specific questions about the Psyche mission, I may be able to answer them. So we do have a member of the team. You know, Lindy kind of has all hands on board for the PDR, you know, but but David Lawrence is on. So you know, people want to, you know, ask questions. We do have somebody from the team on. Tom Statler does have a question. Is anybody doing spectroscopy on Psyche? Because that was my big question. Okay, I had that question. So here's Psyche. You know, it looks like, you know, the density is more kind of in the stony S-type asteroid. It's heavy though. It's heavier than normal. What do the spectra say? You know, is anybody? You know, I think the albedo, the radar. Here's where we get back to radar. The radar sizes, you know, yielded an albedo from radar of about 0.37. So the albedo is high for an S-type asteroid. It's more in the M-type. So does anybody want to say something or put something into the chat?
Yeah, Bonnie, this is David Lawrence. I'm not the expert on the spectroscopy. If you're talking spectroreflectance, of course, I'm the MRA neutron spectroscopy. But
yeah,
I think part of the challenge is, you know, the information we get doesn't appear to be completely consistent, which makes it so interesting. So, you know, I think there's some indication from the spectral data from Earth base that, you know, you have some silicate abundances there. There's indications that you have some water, you know, some sort of hydration features. But, you know, getting there and getting the composition is, I think, going to be one of the main keys for this mission and understanding what Psyche really is about.
thanks, Dave.
Yeah, I saw there's a note of Patrick Michel, you know, there's a silicon hydration bands. And I mean, the other interesting thing from some of the Earth-based measurements is it does not look spectrally homogeneous.
We lost you, Dave. But I heard it does not look spectrally homogeneous. So there's a note here, interesting note from Patrick Michel that says, if you had a iron core and hydrated projectile impacting at up to 7 kilometers per second, you would have an iron target with coating of silicate and hydrated minerals. So that's, you know, an interesting hypothesis. And there's a citation to a paper there in Science Advances 2019.